meeting yet, but let's see. I think she'll show up in a second. But yes, at least we have something we can work with today, and I will hopefully not be as unprepared as I was with the last days when we did some tasks. Okay, may I ask you, how did you get along with the tasks of day 5? So the topic was equations and inequalities. Were you able to solve some tasks? What did you think about the material? Just let me know. Is there anything unclear? Anything general? Okay.
So yeah, some slight problems with solving inequalities, especially the one with the quadratic inequalities. And yeah, sounds like the last both tasks of 24.
Okay.
Overall, it was okay.
So the last two subtasks of topic 24. So this would be 24E and F. Any other subtask? Any specific one?
Not really, no.
Okay.
Just the inequality thing.
Inequalities, just a second. This was task number 25.
24. Yeah,
24. 25, yeah. Okay. Yeah, let's see, because in the forum there were some requests. So these were about task 22 S and V, about 24 C, E and F. So this is very good. So we don't have to go for this twice. 25 L and P. So there are actually a couple of requests for today. And I would say if there is no organizational question or something, we should get started right away. So the weekend will approach earlier. Okay. So let's dive into the task number 22. Just let me have a look at the task set. Yes, so 22 was the first topic, which was just solving equations of different kinds. So let's start with the first requested. Okay, the first requested task was 22S. Is there any other subtask of task set number 22? One of the first subtasks, maybe we should go through, or if it was no problem for you to solve them, would be great to see some green reactions in the chat or among the participants. Okay, one green reaction, second green reaction. All right. Okay. I'm not sure, is whoever asked for the task 22 S and V in the forum, is she already here? Because I don't think she is. I remember I saw her among the participants in the last meetings. That's why I would prefer not to start with solving this particular question, 22 S and V, before she's not here. Okay. Yeah, then maybe we could start with another task, which but she requested these ones as well. What about 24 E and F? But just a second, I have to look at the forum again. Yeah, okay, she requested 24 C, E, and F, and 25 L and P. So basically everything I've written down. Okay, we'll wait for another, let's say, 5 minutes for her to show up. Otherwise, we will start with the first of her requested tasks, but maybe we can start off with one of the other subtasks of topic number 22. So what about, let's say, task 22 E? Let's do this one. So task 22E. Task in this case was 4 times 1 plus 2x equals 3 plus 2 times 1 plus 4x. Okay. Who has a solution for this task or a solution approach, a derivation? Tom, green reaction. Would you like to explain it to us? Or could you even share your screen and show us what you've written down?
Sadly, no, because I'm currently on vacation and I have to do it on paper.
Oh, okay. No problem. But you can write me what to do, or tell me what to do.
I can dictate it.
Yes, please.
So at first I just cut off the parentheses. So 4 times 1, so 4 plus 8 times x equals to 5, and 5 plus 8 times x. So where we already see that there are on both sides 8x, so they also cut off, and then we come with 0 is equal to
yeah. So yeah, it's
minus 1.
Yes, in this case, it's correct to say that these two. Yeah, is it right to say they cut off each other? I don't know, but yeah.
I don't have other.
Yeah, I'm not sure.
Neutralize. Anyway. I don't know.
Yeah.
Okay.
Yeah. Any native English speaker here who knows? No, and let's just say they cancel each other or something.
Yeah, cancel. Thanks.
Yeah, they cancel. They cancel out. But yes, in this case, it's totally correct. But for instance, in other in terms of other tasks, there may occur some problems. So that's why it's always better to write down the specific calculation you have to do in order to cancel them. So I would always recommend you, even if it's quite clear that they will cancel, to write down what you have to do to both sides of the equation in order to cancel the terms you want to cancel. So in this case, we would have to write down that we are subtracting 8x from both sides of the equation, and this would give us 4 equals 3 plus 2, which is 5, as our final result. And yes, as you can see, we are ending up with a false statement. So again, we are dealing with the topic of statements in this case. So you could say that this is a false logical statement. And in terms of if we are dealing with equations, this is implying that the equation has no real solution. So I'm always writing down the real because it's not written down in the tasks, but for every task we are currently dealing with, we always expect x to be a real number. So that's why I'm writing down no real solution, because there might be a solution among the complex numbers, but since you have not dealt with complex numbers, at least the most of you will not have, we will keep it with the real numbers at this point. And yes, if there's such a kind of a false logical statement as the result of your derivation, then this shows you that the equation has no solution among the real numbers. All right. Now I can see Shifat has arrived among us, so we can start with the requested tasks out of the forum. At first, thank you, Shifat, for doing the entry into the forum. I've had a look at the tasks before the meeting, so I'm at least a little better prepared than the days before, and so I hopefully can deal with the tasks quite confidently. All right, so let's go on with the requested task number 22S. 22S, just a second. There we go, 22S. The root of 15x minus 40 By the way, is it your first name, Shifat? So can I call you Shifat if I want to address you? Okay.
Yes, you can call.
Oh, okay. Yeah, you're pretty hard to understand, but I can see that you wrote into the chat that you're outside. Okay. Yes, but I hope you can hear me properly because yeah. Okay, but if you're outside, I won't require you to talk to me. But if you can hear me, everything's fine. Okay. All right. What can we do about this task number 22S? So is there any idea what we could do? Or yeah, maybe if you can speak or can talk to me, you may tell me what your idea was about to solve this task. Okay, maybe one of the others. Okay, in the chat she wrote down squaring both sides after leaving root side alone. Okay, very good. Let's do this. So what can we do in order to leave the root alone on one side of the equation? Of course, as you can see, there is a sum on the left-hand side of the equation. So there is a sum of the root and the term 3x. And in order to get rid of the term 3x on the left-hand side, we just have to subtract 3x from both sides of the equation. And then we'll have the root standing on its own on the left side. And on the right-hand side, we have 8 minus 3x. And now Shifat wrote that we could square both sides of the equation. And then this will cancel the root on the left side. So in this case, there is nothing like having that we have to use modulus operation or something because we are canceling a root by squaring. This is always not a problem. So there's no problem about canceling a root by squaring. The other way around, this would be another topic. Because if there would be something like a square and you would like to cancel this with a root, so like this, then we would have to have a look at this. Or yeah, at least if you want to use a root as your operation in order to solve an equation, then you always have to be careful. But in squaring is never a problem. So you can always square both sides of the equation and that will be totally fine. Okay, so in this case, this cancels the root on the left side, and on the right-hand side, yeah, what will be left on the right side of the equation? Anyone? You can. It's yeah. Whoever wants to answer.
Square minus 48x plus 64.
Okay. Right? Again, please. Yes.
9x squared.
9x squared
minus 48x plus 64.
Correct. So you applied the second binomial formula at this place. Correct. Yeah. What could we do next? Of course, we could think of simplifying the polynomials on both sides just by, yeah, getting all summands on one side of the equation. So if we would try to get the 15x and the 40 to the right side, we would have to subtract 15x and we would have to add 40. Because in this case, we would be left with 0 on the left side. On the right side of the equation, this would be 9x squared minus 48 plus 15, because both of them are getting subtracted. So 48 plus 15 is 63 minus 63x, and then plus 64 plus 40, of course, 104. So next thing to do. What would it be? Yes, you could use a calculator for this, but unfortunately, the task sheet tells you not to use a calculator. So it's always at the bottom of the task sheets, the note that you must not use a calculator in order to solve the task. So what can you do if you don't have a calculator with you?
It's not written on this task.
It's not written on this sheet.
Yeah.
Are you sure?
Yeah. I think I'm sure.
Just a second. I have to check about this. This would, okay, then I would have a problem.
By the way, I didn't know when he said, I don't know the name, sorry for that, my friend, but when he said, I just checked it and it's not written below.
What about this down here?
Wait, oh, I'm so sorry. I just look at the solutions. I'm sorry.
No problem. But yes, it's quite clear. So the task sheet's quite clear about this. You're supposed not to use a calculator. All right. So what could we do if we don't have a calculator with us?
We have to perform middle term here, right?
What do we have here? What kind of term?
Middle term. We called it like that.
Okay, I didn't get the word, but
there's a rule to perform this type of math.
yes. What is the formula called? Does it have a name? ABC formula, correct. So
yeah,
actually,
ABC formula. Yeah.
okay, yeah. I have to admit that in Germany, it's not that kind of common thing to use the ABC formula. I know that there is an ABC formula which looks like I'm not sure about it, 4AC or something, and square plus minus square something. But I can't remember this formula because we actually don't learn this at the German schools. But there's another formula which is quite popular in Germany or among German students, which is the PQ formula. And I hope that if you were studying the material folder for today, you also came across a video about the PQ formula. And yeah, maybe some of you also know that there's another condition which has to be met before you can apply the PQ formula. So, and Shifat already wrote into the chat that we had to do some kind of factorization, and that's totally correct because the PQ formula requires us as a condition that we have an equation which looks the way 0 equals x squared plus p times x plus q. So it is very, very important for applying in order to that we can apply the PQ formula that there is no factor in front of the x squared, or better to say there's a factor of 1 before the x squared. So that's why we would have to do the following before applying the PQ formula. Yeah, of course, you could call this factorization, but not in every case there's a common factor that all numbers, for instance, share the common factor of 9. So you could just get rid of the factor by factorizing. But what you, of course, you can do the following. You could just divide your formula or your equation by 9, so by the factor which currently is in front of the x squared, because the left side of the equation will always be 0 at this point, and if you divide 0 by any arbitrary number, this will just remain 0, and that's why this is the way you should do this. And the PQ formula is a lot easier than the ABC formula, at least for me, it is. But of course, the advantage of the more complicated ABC formula is that the ABC formula does not have this condition that there needs to be a 1 in front as a factor of the x squared. So the ABC formula could already be used if you have the expression in this shape, But in order to use the PQ formula, which is the most common thing to do among German students or German students, would be to get rid of the factor 9 in front of the x squared. So what we would do about this is to divide by 9. And now this will lead us to x squared minus, 63. In fact, has 9 as a factor, so this would be 7x plus, and 104, unfortunately, is not divisible by 9, so this would just be 104 ninths. Okay, I write down PQ formula again. Now it's time to apply the PQ formula. And the PQ formula. Who remembers the PQ formula? Nobody. Did you all deal with the ABC formula? Then I would have to have a look at the ABC formula.
Minus p half plus minus root of p half squared minus q. But I on much occasions I found the ABC formula way simpler because they have no common factor or aren't clearly dividable by any number. So you just apply the ABC number.
Then what about, why don't we do this today? I'm here to learn new things too. So let's do this. Let's apply the PQ formula because 104 ninths is quite ugly. I admit that. So let's use the ABC formula. Could you tell me the ABC formula? Because I don't know it. I have to rely on you.
It's minus b plus minus the root of b squared minus 4ac 2 halves. Also, geteilt durch 2a. I don't know.
This way?
No, the minus b plus minus above.
I can't hear you anymore. Sorry.
The minus b have to go on the denominator.
Ah, all right. Yeah. Now I remember. At some point I saw this for once, but yeah. So this like this, right?
Minus b.
Minus b. Okay. Yes. So this is the ABC formula. Yes, please.
Still, like in the root, it's like b squared minus 4ac.
Sorry, b minus 4ac.
No, b squared minus 4ac.
Okay. All right. Okay. So now I have to learn something new. Or I have to adapt at least to something new because I never did this. But of course, this is another way to solve a quadratic equation. So let's do it. In this case, a, of course, is the factor before the x squared. B is the factor of the x, and 104, or c is what is left without x. All right. So what about this ABC formula? If we insert our factors from above, we will end up with, so this will be minus 63. So we'll get plus 63 plus minus b squared. So this will be, this will be 63 squared minus 4 times 9 times 104. This might become quite hard without the help of a calculator, but let's see. Okay. Is that correct like this? Or
Seems fine.
okay.
Yeah, that's
Let's-
correct.
Let's go on. Yes. So what about this? So we have.
By the way, we are open your formula. By the way, I mean,
Sorry?
really interesting your formula, PK formula.
Yeah, you
Okay.
have written 2 times 18. It's just 18. And the denominator.
Yes, correct. Yeah. Okay. It's too fast about this. All right. So how can we solve this without a calculator? Although there's an expression like 63 squared. So this is quite hard because I don't know the term 63 squared. And yeah, but I think there should be a way to deal with this anyway. Okay, so 63 could be split up to 7 times 9, which is quite interesting because we have a 9 in the denominator as well. So this is a good thing. And then we have 63, which could be again be dissolved to 7 times 9. So we could just write 7 times 7 times 9 times 9. If we do the square, minus 4 times 9 times 104. Okay. Now we can reduce the fraction like this. Yeah, but we will still have a problem about the root. So of course this is just canceling with the first summand in the numerator. So we'll have 7 halves plus minus this root. Yeah, okay. I think in this case you won't. Yeah, this is quite silly to do this without a calculator because, yeah, of course you can do it, but actually I don't want to do this without a calculator. Yes, but in case of the PQ formula, you wouldn't be so you wouldn't have to use a calculator because the numbers would have become smaller and after you would have divided by 9. So actually,
The
this
denominator is 2. It's not 18. We can't.
Yes, it is 18 because the 9. We have two. We have a sum in the numerator. So before we did the reducing of the fraction, we actually split up the fraction into 2 fractions. So you could write this as this, and you can only cancel the 9 here.
I am not quite sure about simplifying the equation, but before we apply the ABC formula, maybe we can simplify the equation by dividing 9. So
yeah, you could do so, of course. Then you would have 104 ninths, and then you would have another fraction because 104 is not divisible by 9. Yes.
No.
Okay, let's do it like this. I'm now using a calculator in order to determine this root in the numerator. So 7 times 7 times 9 times 9 minus 4 times 9 times 104. Yeah, okay.
It should be 15.
It's 15. So yeah, somehow you would have come to the conclusion that this is 15. But yeah. Okay. I'm glad I have a calculator at this point. So next step would be, of course, 15 divided by 18 could be reduced to by 3. So both could be divided by 3, and this would be 5 divided by 6. And 7 and 2, you could extend this fraction to be to have the denominator 6 as well by multiplying 3. And then this would be 21/6 plus minus 5/6. And this is, so this leads you to x1 equal to 26 divided by 6, which is 13/3.
21.
And yes, what about 21?
It's 21, not 26. Oh, you added them. Okay,
I
got it.
added them,
Okay.
yes. So yeah, of course, this plus minus means that we'll have two results. So one result is 21/6 plus 5/6, and the other one is 21/6 minus 5/6. And 21 minus 5 is 16. 6, and this is 8/3. So now we have another thing to do, because at the end of solving an equation, you always have to insert your presumable results, your, yeah, what's then the English word for this? Just a second, let me check. The provisional, preliminary, vorläufig in German, your preliminary results by inserting them into the original formula. So let's get these two results back into the original formula, which was root out of 15x minus 40 plus 3x equals 8. So let's start with our second result, which was 8/3. So if we insert 8/3 here, so yeah, okay. No. So this is about x1. Yeah, 15 could be reduced with 3. So this is going to be 5 times 8, which is, of course, 40. So this would be 40 minus 40 plus, and 3 and 3 are also can be reduced to 8. And as you can see, this turns out to be 0 plus 8 equals 8. And of course, this is true. What about the other result, x2? In this case, it's going to be 15 times 13/3 minus 40 plus 3 times 13/3 equals 8. What about this? So again, 15 and the 3 in the denominator. This is going to be 5 times 13, which is 65. So 65 minus 40 plus, yeah, okay, 3 and 3. This is going to be 13 as well. So 13 equals 8. And now you can see one thing. This is going to be, okay, yeah, we can calculate it. So because this is going to be 25, and we know that the square root out of 25 is 5. So this is going to be 5 plus 13, which is 18. And as you can see, this turns out not to be a correct result. So how can that be? And that's why it's very, very important always to check upon your results. Because after you have applied either the ABC formula or the PQ formula, your results will always be preliminary. And you always have to check whether they meet your original equation, especially in case it was not a quadratic equation at the first place. But can anyone think of a reason or can explain why there is a false solution showing up here? Or why is it a false solution? Because actually the ABC formula uses to work, and it uses to give you two correct results. But why does it fail in this case?
Probably because we squared in the first place, so we squared off the root, and there is just one possibility of a root if there is a negative root.
Yes.
So
So actually, if you want to be very specific about this, this has something to do with the so-called domain of a root function. Of course, we will deal with functions next week, and you didn't know about functions yet. but yeah, this is the actual reason for this, because the first thing about any equation you want to solve is that you have to determine the domain of both of your first terms on the left-hand side and on the right-hand side. If there are any kind of limits or any kind of, yeah, how to say it, any kind of restrictions which could occur because of the shape of the terms. And on the left-hand side of our original term, there's this, or better to say, what is restricting us is the root. Because we have an x as part of the radicand. And when we know one thing about roots, and this one thing we know about roots is that a root, if it has some kind of argument, I call this y right now, then this argument has to meet a certain condition in order to be a valid solution to any equation which goes like, like this is equal to anything. So this always needs to meet a certain restriction, which is that y must be greater or equal to 0. So in every case, the radicand of some root must be greater or equal to 0. And that's why actually the first thing you have to do, we didn't do it this time because I wanted to show you that otherwise you could end up with false results. But the first thing you would have to do is to determine the domain of this equation, or the domain of the two terms of the equation. So what does it mean for our example? So just a second, I could leave this. So if you have root out of y, this would require that y is greater than or equal to 0 in order to go forward with this.
I want to say something, like there is an easy way to do this type of math. Can I share that?
Yes, please.
Then I have to share my screen. May I?
Yes. Okay, but just a second. I think I have to stop sharing my screen then.
Okay.
Yes, please.
It may take 1 minute, okay?
Otherwise, I could finish first, and then you could show your approach. It will take just a minute, so you could get ready. So what does it mean for our example? So if we keep dealing with our root 15x minus 40, this means if we have 15x minus 40, this needs to meet the requirement that 15x minus 40, which is the radicand, must be greater than or equal to 0. And this is another inequality we have to quickly, it's an easy inequality. That's why we can just quickly solve it at the beginning before we would start with doing anything else about the equation. So the first thing would be to solve this inequality in order to determine the domain of our equation. And first thing to do would be to add 40 to both sides. This would be 15x greater than or equal to 0. And afterwards, we could divide by, 40, of course. And then we could divide by 15, and this would leave us with x greater than or equal to 40 divided by 15. Yes, just a second. And 40 by 15 could be rewritten as, of course, you could divide it by 5. So 40 divided by 5 would be 8, and this would be 8/3. Just a second. I have to think about this again because some may have did some kind of a mistake. Just a second, because actually 13/3, of course, is still valid at this point. So maybe this is not a valid explanation at this point. Because of course 13/3, our second preliminary result would still match this condition. And now I'm confused a little bit by myself, because I thought this would solve our problem, but it does not. Okay, I'm sorry about that. Then there is another reason for this. I don't know currently, but of course the problem is that we somehow got rid of the root in order to get ourselves a quadratic formula. And maybe if some of you have already heard of functions, then they know that if you have the inverse function of a root function, this of course, yeah, it is a quadratic function, but a quadratic function always looks like this. So it is its domain is the whole real numbers on the x-axis, while any root function only looks like, only looks like a half parabola. So a root function would always look just like this. So this part is missing at this point, and I thought this would be a way to show this to you without telling you anything about functions. But actually, I seem to be wrong at this point. But maybe whoever just told that she had any other way to explain this problem. Are you ready?
Yes, I am.
Yes. So please show us your explanation. I'm going to think about mine again.
Can you stop sharing? Then I can share.
Yes, I'll do.
Is it visible?
In a second. Just let's wait for a second. Not yet. Now we can see your screen. Okay. Could you explain it to us?
Yeah. First, we have 9x squared, so we can find that 3 into 3 is 9. So we wrote it down. Then if we divide 104, then it became 2, 2, 2, and 13. All are like real number. So after that, we multiply 3 into 222 equal to 24, and the least 3 and 13 became 39. After that, we know that our duty is to make 63. So 24 and 39 is equal to 63. So after that, I just put minus sign before them because it is in minus. Then it became minus 24x and minus 39x. After that, we take common, and then the result became 8/3 and 13/3.
Okay, interesting. Is there any kind of systematic procedure behind this? So could you do this about any quadratic expression?
Yeah, we can do any equation by this formula. I have found this morning in a YouTube video. I can share that as well.
Okay, yeah, would be interesting. So what exactly were you doing at the beginning? So you were doing prime factorization to the first and the last factor, or the first factor of x squared. And
actually, we have to make somehow 63. That's why it doesn't matter. We have to multiply these terms. It maybe can like these two, or maybe these two, or like somehow we have to make 63. Then it will be easy for us.
Okay. Never heard of this solution. This way to solve a quadratic equation.
It was actually in one I mentioned in one of the videos of the materials just there.
Yeah, okay. Actually, I did not do these material folder collections. I have to admit, and I have to admit that I did not have the time to go through them. But yes, then this might be a very quick. Looks like a very quick way to solve quadratic quadratic
Yeah.
equations.
Simon,
Yes.
this solution, is it systematic to solve? I mean,
Yeah, I asked Annika
Or
about this
to-
a minute ago because I'm not sure about the systematic procedure yet, but because okay, I saw it for the first time right now, but I think there is some kind of should be because Annika managed to solve this task with it, and there
Yeah,
seems
and the
to be
answer
some
is
kind of
right.
system.
So
All right, maybe could you explain it again very, very slowly for everybody, so maybe we can all see the system, how it works. So what was your first step in order to solve this? So,
my first is to divide divide the big term into a smaller term, like 3. Like if I divide 3 into 3, then it will become 9, and I cannot divide 3 anymore. So it's the least number. So we have to take a least number and then we multiply them to make 63. That is the rules actually.
but you use your instinct, so it could be 9 and 1. So how did you decide 3 and 3x?
Yeah, it could be 9 and 1 too, but yeah, it's a good point. But I think 3 and 3 is the easiest way to do this. That's why, yeah, that's a good question, but I didn't use it. Like
So
I
you follow
somehow
your
solved it.
you follow
I
your
can share
instinct,
the
right?
YouTube video so that will solve everything. Like I can explain it properly, so the YouTube video will help. I am sharing the link right now.
yeah, but because
the
this
way,
is a very yes, please.
I appreciate your solution.
Okay.
Yeah.
Okay, I'm stop sharing.
Yes, very interesting way to do it. But of course, you would have to use your instinct, as the other guy said, in order to find that 63 could be made out of 39 plus 24, and then you would have to find a way to create 24 and 39 out of the prime factors.
Yeah.
Don't know if this is very easy, isn't it? Is it very?
No,
is it
not
easy?
that easy, but it takes a shorter time than doing the PQ formula or ABC formula.
Okay, yeah, I guess could be. Okay, interesting. I'll have a look at this again.
Okay.
But of course, for now, I will, because I have to be sure about it, I will stick to my way I'm used to.
Yeah, obviously, I'm just sharing the optional reason.
Yes. Okay.
This is a perfect way to solve multiple choice questions, but in the exams, it doesn't help too much. That I have experience in my math exams, but yeah, it's a good solution.
All right. Yes, just a second. Yeah, I still don't know why I can still provide you any good answer why 13 thirds is, so any logical answer why 13 thirds is not a proper solution. But of course, if you check upon your results, you can see that 13 thirds does not match the original equation, while 8 thirds does. And yeah, in case of this task, because one of the results actually works, this may encourage you to be sure that your derivation was correct. But yeah, okay. Actually, I would become insecure about my result if one of the two results is not working, and I can't see any reason. Yes, but actually, I put it into a graphic calculator, and I could see that there was no solution for this. This bothers me right now because I can't see why 13 thirds is not a proper solution for this. Of course, as I showed you, it's logical in some kind of way because every root function looks like this. So just the people who don't know anything about functions, you must just close your ears right for a second. But those who have already heard of functions in former times, of course, a root function looks like this. And if you have let's say this point is 8/3 on the x-axis and this is 13/3, there is no way that these could end up at the same height on the y-axis. So whenever you have two different x values, you will always end up with two different y values in case of a root function, while in case of a quadratic function, of course, there could be two different points on the x-axis where the function has the same height. So yes, in terms of a quadratic function, there will always be, there could, or at least could always be two solutions, but in case of a root function, it's quite probably that one of the two solutions is going to be false. But yeah, this bothers me, and I'll think about this for the whole weekend, I guess. But maybe there was no good explanation. But I'll think about one again. And yeah, for now, I can only encourage you to always check your results after you found them as preliminary results, following your PQ formula, ABC formula, or your whatever way to find the
I
result.
have seen the YouTube that this actually works. So I have sent it in the like chat box.
Okay, so your solution approach you just showed us. Or what
Yeah.
do we mean? Yes, yeah. Okay, so I think this is, yeah, it's a very interesting thing. I'll watch it after you after our meeting.
Okay.
All
sure.
right. Yeah. Okay, so let's say this is everything I can tell you about number 22S. And in fact, there's just one solution at the end. So the only solution to this task is x equals to 8/3. Even though I cannot tell you why 13/3 is not a solution, so I can't tell you any mathematical reason for it. But yeah, maybe I'll find one. But x equals 8/3 is the only solution that works for this task. Okay, any question?
Nope.
Okay, very good. Then let's proceed with the next requested task, which was 22V. So task number 22V. 22V. 2x minus 5 minus 3x plus 4 equals 1. How can we solve this? No one? Otherwise, I'll just show my
First things
idea.
first, squared.
So you just start with squaring the whole expression?
Yeah.
Yes, one possible way to do. So what could we, yeah, what would this do to our equation if you square both sides?
It is going to make more complicated.
Yes, of course, but yeah, in order to solve equations with roots inside, you will always have to square at some point. So yeah, of course, you could just think of moving one square to one root to the other side, but in the end, you would have to do the squaring anyway. Okay, so let's do the square right away. What does it do?
It will give us 4x squared plus 25 minus 9 squared, 9x squared plus 16 is equal to 1.
You sure about this? So let's write it down at first like this, 2x minus 5. Okay, on the right-hand side, it's quite clear that this is going to be still just 1. But what about the left side? What is that? What does this remind you of?
Oh, now it's the second binomial formula. Yeah.
Correct. So the second binomial formula, and in this case, this term would be a, then you'd have minus, and this term would be b, and this whole thing is squared. And now the second binomial formula tells you that this is equal to a squared minus 2ab plus b squared. So let's do this. And yeah, what is a squared? Is it 4x squared plus 25? Or what did you, or whatever you said? You said something like 4x squared minus 25 or plus 25 was anything like this.
Yeah, you mean me. Yeah, it's 4x squared plus 25.
Okay.
Would
Are you
be
sure?
a.
Because actually it would be something like this is a, and now we
Yeah.
square it.
So yeah, okay, so now we squared.
So if we do this, then we'll just cancel the root, correct?
Oh yeah, you're right. Yeah.
So there will be
it's
nothing like
2x
4x
minus
squared.
5.
It's just 2x minus 5.
Okay.
And yeah, then we'll have minus 2ab. What is that? Minus 2ab. So minus 2 times square root 2x minus 5. This is a, times square root 3 plus 4. And then plus b squared, which is
Yeah, then of course just 3x plus 4.
3x plus
4.
4. Okay, so this would be our intermediate result. Of course, this is much more, it looks much more complicated than before, but yeah, as unfortunately, you have to do it this way in order to solve the equation. Okay, what next? Any idea? No? Maybe it would be a good thing to have the root on one side alone again. So every root, which we have currently in our equation, would be good if this could be alone on one side of the equation. And that's why we would have to try to pull everything without a root to the other side. If we want to do this, then of course we have to subtract 2x. We have to add 5. We have to subtract 3x. And we have to subtract 4. Yeah, I know some of you already spotted that we could also get these together to say we are subtracting 5x and adding 1. But yeah, I wrote it down like this again, just to make it clear to everybody. On the left-hand side, then we would have negative 2 times 2x minus 5 times 3x plus 4. And this would be 1. Okay, so minus 2x minus 3x, of course, is minus 5x. And then plus 5 minus 4, so plus 1. And this would be just 2. Okay, what could the next step look like?
Dividing it by -2, so we get rid of the factor in front of the root.
Yes, would be an idea, but actually we don't have to do this. Yeah, it would be possible, would be nothing wrong about it, but
Then probably squaring the roots.
yes, so we would have to square again in order to get rid of the remaining roots. But this time, hopefully, there will be no other roots remaining in our equation. But let's see what happens. So if we square again, what does it do to our equation? What about the left side? Of course, this is the last subtask of the task set 22, and that's why it's a kind of a hard task, a difficult task. But yeah, it's doable. So what would be the left side of the equation after squaring? Come on. Get your
Roots
remember.
will cancel, and -2
Yes, I
squared
just
is 4.
want to tell to remember the rules for exponentiations. So if you have a product, so in this case, of course, we have a product on this side, on the left-hand side. So -2 times a root times another root, and the exponentiation rule about squaring a product told you that you could just do a squared times b squared in this case. So in this case, again, please, what did you just say?
Will be 4 and the roots will cancel.
Okay, yes. And this would lead us to which result?
4 times 2x minus 5 multiplied with 3x plus 4.
Like this?
Yes. Yeah.
Are you sure?
And so parentheses about
yes, very, very important. Otherwise, this would not take a good end. So parentheses are very important because if you cancel the roots, this expression was the radicand as a whole, and that's why you have to put parentheses around it. Okay, and what about the right side of the equation?
We have to use a minus b whole square formula here. It would be become 2 square minus 2 into 2 into 5x.
2 times 2 times 5. What is 2 times 2 times 5?
20.
Correct. 20 plus
25x squared.
Correct. All right. Yes. What next?
We have to multiply 2x minus 5 into 3x plus 4, and lastly with the 4.
Yes.
In the right.
Maybe I've got a better idea. Yes, this could be a better idea. I just see this. I don't have this in my sample solution, which I did before our meeting, but I would recommend write down this like that at first. Because if we square the expression, then of course this would be what we actually calculate. Can you see that? So if I do 2 minus 5x whole squared, this is exactly the same, right? And now maybe some of you already can spot that we have the, oh, sorry, we don't have, okay. I'm sorry, and I never said anything. Okay, so back to what we had before.
I just saw the same thing.
Yeah, but it's not true.
Yeah.
Okay, sorry. I hope this will work with just pushing redo. The redo button doesn't work properly in OneNote. Okay. It doesn't react anymore. No. No. Okay, we'll have to wait for OneNote for a second. I can write, but I cannot
And
erase.
that's it why you shouldn't use Windows.
Yes. No. Yeah. Maybe. Okay. Now I think it should work again. So if we do the squaring, we already figured out that this would be 4 minus 20x plus 25x squared. And now we can do our next step, which would be to just do some calculation, right? So we could expand the parentheses on the right, like multiplying these, and these. So the 4 would remain at the front for a second. So we have to use new parentheses in this case. So still big parentheses, because actually we have to, we are still doing a multiplication, and inside the parentheses there is plus and minus, and that's why we have to use new parentheses, because the 4 is not a part of the calculation already. And now we can do the expansion of the parentheses. So 2x times 3x is going to be x squared. 2x times 4 is 8x. Negative 5 times 3x is minus 15x. And negative 5 times 4 is plus 20. And on the right-hand side, it's 4 minus 20x plus 25x squared. Okay. Yeah, what next?
And 24x squared.
Again, sorry.
24x squared. Plus
4x squared. Did you say 4 or
24.
24? Yes. So we could expand these these parentheses, right?
Definitely, yeah.
Okay, let's do it. So 24x squared plus
32x minus 60x plus 80.
Correct. Yeah, and now it starts to look easier to us. But yeah, of course, what's the next step? We could, just bring everything to one side. So we could subtract 24x squared. We could subtract 32x. We could add 60x, and we could subtract 80. Of course, you could do some kind of simplification at first. So 32x minus 60x is negative 28x. So you could also, this is, just a second. This is negative 28x. So that's why we could just simplify this to plus 28x. Okay, and then the equals 25x squared minus 24x squared. Wow, it's just 1x squared left. And then minus negative 20x plus 28x is just 8x. And 4 minus 80 is going to be minus 76. Yeah, and now we can either use the ABC formula or the PQ formula. In this case, I'll do the PQ formula because some of you requested it in the chat to do the PQ formula as well. So in this case, we'll use the PQ formula. And I said earlier that there is one condition for the PQ formula, because the condition is that there is a factor of 1 before the x squared. In this case, this is already given. And PQ formula goes like the following. Who knows? Who wants to tell me PQ formula? Let's write it down here. I think someone put it into the chat earlier. Okay, so yeah, it's actually, you can look it up if you don't know. So minus p halves plus minus p halves whole squared minus q, with p and q being the factors of x and the number without an x. Now, what does it mean for our example? In this case, we would go with p being 8 and q being negative 76, right? So this is p and this is q. Who wants to do the insertion? Sorry, I cannot hear you. I'm so sorry, your bandwidth is too small. Your connection is too bad. I can't hear you. I'm sorry, but I hope that you said the right thing, which would be negative 8 divided by 2. 8 divided by 2, of course, is 4. And then plus minus square root. Of course, 8 halves is still 4 squared minus negative 76, so plus 76 in this case. Right, and this is negative 4 plus minus 4 squared is 16, and 16 plus 76 is 92. Just a second, let me check. This does not seem to be my day, actually. Because I suppose this to, no, okay. Let's see. So there would be 2 results for x in this case. First result would be negative 4 plus square root of 92. And x2 would be equal to negative 4 minus square root of 92. Okay, root of 92, I don't know if we could make this any easier. Of course, 92 is 46 times 2 is 23 times, yeah, it would be 23 times 4. So we could do something like, yeah, but I don't think that it's worth it. So you could write something like 2 times square root of 23, but I don't think that is better than root out of 92. Yeah. Okay, so let's leave it with square root out of 92. Yeah. And at this point, you have your preliminary results and you would have to check if they match the original equation. So the original equation was, 2x minus 5 with a root above minus root out of 3x plus 4 equals 1. And yeah, again, now that's why I'm not very happy about this, is that, of course, this is not a very good thing to solve without a calculator again. I have to talk to the people who are responsible for the task sheets, because this is not a thing you could solve with a calculator. Yeah, but if you enter the preliminary results into the original equation, let's do this for a second. If you give me 1 minute, I will enter them to my calculator. So 2 times negative 4 plus square root 92 minus 5 minus new root 3 times, again, negative 4 plus square root out of 92 plus 4. And this is, yeah, so if I enter the first result into the original equation, I will end up with negative 2.071 equals 1 Of course, this one is false. And yeah, I can do the second one. Just a second. Minus instead. If I do this, I will even end up with a mathematical error at this point. So that may be because, of course, this is a very negative number, so -4, and then I'm still subtracting something which is greater than 0. So I'm actually having a quite big negative number. If I insert a negative number in here, in here, if I have a negative number times 2, it will be an even bigger negative number. And then I'm also I'm even subtracting 5 from it. Then I want to do the square root. Yeah, so this is quite clear why it does not work, because I can't take the root from a negative number. And so, yeah, it's quite clear in this case why the solution x2 does not work. But the solution x1, I again have an explanation for you why it does not work. But if you check it with your original equation you were given at the beginning, in this case, you can see that every work you've done was done for nothing, because at the end, your final result is that there is no real solution. Wow, this is very frustrating. We should have done some task with a solution, but yeah, this was the task which was requested. And yeah, sorry about that, but there is no real solution. And I think also the sample solution tells you that there is no solution for 22V.
Especially in the exams.
Yeah, in the exam, this would be very confusing, but I can assure you that in an exam, you wouldn't be given such a task where there is no solution at the end. Of course, yeah, why not? Okay, yeah, it could be. Of course, you're getting a lot of the points in an exam for your derivation, so for your way to the result. But yeah, actually, most of the professors are kind enough to give you tasks with nice results. Okay, wow, that's a very frustrating so far. Yeah, what about having a little break before we head on to the other tasks requested? So I have a little time for myself to think about why this is not working with the 13/3 and this first preliminary result, but I don't think I'll come to a conclusion so quickly. But yes, what about a break? Green reaction, 1 green reaction, 2 green reactions, 3, 4. All right. Yes, perfect. It's 10 to 6, so let's do our break until 6 p.m.